Hello and welcome back to the physics class. Today's topic of discussion is nuclear fission, which is a very important reaction of radioactive decays. These are the paragraphs and important statements taken from your textbook. So it's the topic 13.7.1 fission. New possibilities emerge when we go beyond radioactive decays, natural radioactive decays, and study nuclear reactions by bombarding nuclei with other nuclear particles such as proton, neutron, alpha particles, etc. So this is not the natural radioactive decay. A natural radioactive decay is the one where the radioactive nuclei on its own undergoes decay. There is no stimulation required to initiate the process. Here in this case, the example in the equation 13.26 shows that there is a uranium nuclei and it is bombarded by a neutron. Uranium has an atomic number of 92 and mass number of 235. When it is bombarded with neutron, the neutron gets absorbed inside and you see there is a change in the atomic mass number from 235 to 236. The atomic number remains unchanged. Now, this uranium nuclei with an additional neutron becomes highly unstable, and in order to gain stability, it undergoes disintegration. Thus, we see that it gives us barium and krypton. Barium has 56, 144 and krypton has a number of 36 and 89. Along with this, 3 more neutrons are produced. So this is a fission reaction where a heavy nuclei splits into 2 lighter nuclei in order to gain stability. This is the pictorial representation of what we have discussed just now. The target nucleus is the uranium 235. It is bombarded by neutron and it gives the fission product. These fission products are barium and krypton nuclei formed. In addition to this, we have the 3 neutrons ejected. Now these 3 neutrons, they are traveling with very high speed and it will go and it may bombard 3 more uranium nuclei. Thus, the process goes on. In every fission reaction, we have 3 neutrons produced which goes and hits 3 more uranium nuclei. Thus, you see, this process multiplies very fast and this is what we call as the chain reaction. So you see, one neutron which has initiated the process gives multiple neutrons and so many fission reactions take place within a short span of time. The same reaction can produce other pairs of intermediate mass fragments. So it is not necessary that every reaction will give us barium and krypton. Like here you see, the neutron when bombarded with on the uranium nuclei, it is giving us Sb and Nb with 4 neutrons. Another example is with the same uranium on the left hand side with bombarded with neutron, it gives Xe, that is xenon, and Sr with 2 neutrons. So it is a combination of different elements which will be formed, and again there is no rule for specified for the formation. It is just the instantaneous and spontaneous process. Now, what is the energy released in these fission reactions? The energy released, that is the Q value in the fission reaction of nuclei like uranium, is of the order of 200 MeV per fissioning nucleus. So you see the value is around 200 MeV. From where do we get this value? We can always work out to see the calculation for this value of 200 MeV. For this, let us take a nucleus with A is equals to 240, which is breaking into two fragments of each 120. Then the EBN stands for the binding energy per nucleon for 240 nucleus is about 7.6 MeV, whereas the EBN value for 120 fragment nuclei is about 8.5 MeV. The gain in the binding energy for nucleon is about 0.9 MeV. This is how we can calculate. Now, if this is the binding energy, the total gain in the binding energy would be 240 multiplied by 0.9. 0.9 is for the one nucleon and there are 240 nucleons, so we simply multiply, which gives us the value as 216 MeV. So you see the disintegration of 240 uranium nuclei, it's a uranium nuclei with A value 240 gives us 200 MeV of energy per fission. This is actually a very high value. The disintegration energy in fission events first appears as the kinetic energy of the fragments and neutrons. Eventually, it is transferred to the surrounding matter, appearing as heat. The source of energy in nuclear reactors which produce electricity is nuclear fission. The enormous energy released in an atom bomb comes from uncontrolled nuclear fission. It is important at this point to understand that fission, when it is controlled, it is very beneficial, and when it is uncontrolled, it is equally disastrous. A fission reaction, when carried out in a controlled manner in a nuclear reactor, it gives us enormous amount of energy which is converted into electricity and which meets our daily needs. Whereas in the explosion of atom bomb, it is the fission reaction that to an uncontrolled chain reaction goes on, and we have already read in the history that during the World War II, the world has witnessed the disastrous effect of atom bomb explosions at Hiroshima and Nagasaki. So you can imagine that such an enormous amount of energy is liberated during these fission reactions. Do read this topic from the textbook. We end the class today here. Goodbye.